We set up a fuzzer experiment where we use AFL and AFL++ to fuzz sudo. These fuzzers started with some test cases given to them, and 2 test cases included the program name sudoedit, while the others only sudo. The vulnerability we are looking for is in sudoedit. So this is an interesting experiment. How quickly do the sudoedit based fuzzers find the vulnerability, and how long does it take for a fuzzer that doesn't even have the initial information about sudoedit need to find that particular functionality? Anyway, fuzzers have been running overnight now. Let's check their status. I just woke up. And of course, first thing is to check the fuzzers. We have found one crash. First of all, I would have expected that the sudoedit fuzzers would have found a crash much faster. And I'm surprised that the AFL version didn't. Also, it's a bit of concern why this fuzzer is stuck with slow execution speed and large amounts of timeouts. While I quickly moved on from here and continued my research and investigation, I can tell you from the future that I have actually let this fuzzer run on the site for over a week or so, and eventually this fuzzer came out of its rut and got back some speed. But it's interesting how that happened. Also, the AFL++ fuzzer that only had a sudo test case and didn't know about sudoedit eventually found sudoedit. The last new path times are also kinda high, over 1 hour here, which means the fuzzer hasn't found any new code functionality in over 1 hour, which can be an indication that maybe the fuzzer explored everything it could easily find. But it's hard to say if 1 hour is a lot or not for sudo. I lack the experience. Anyway, let's look into this crash. First, I want to check the crash input file itself and look at it with hexdump. I would have expected that it found a variant of the vulnerability with sudoedit -s or so, but apparently it didn't. However, this input does have a backslash, so maybe we found another variant to trigger the sudoedit bug? Or maybe this is a false positive and this is not really a crash. So let's try it. I copy this crash to tmp crash, then I cut to send the file data as input to the instrumented AFL sudo binary, and we get a malloc error. Invalid next size unsorted, aborted. Now maybe this is just again a thing with our instrumented binary. So let's try it with our need AFL sudo wrapper, which sets up the arguments and calls the real installed sudo. And when we do that, we also get a malloc error. Awesome. Now I'm getting excited, but let's do one last test. Now switch the user to the unprivileged user. Remember, sudo is intended to run as setuid called from an unprivileged user. So let's try this again and see if we reach this seemingly crashing code. And indeed, we also get a malloc error. Perfect. Let's look at this in GDB. For that I installed the GDB extension Jeff. You can also use pwn-debug we used last time, but I just wanted to show another extension. In this case, I GDB debugged the AFL2 sudo wrapper as we need it to properly set up the arguments, and then we pipe in the input. The binary will execute now, set up the arguments, and then exec the real sudo binary. And then we crash. It's not really a crash, it's an abort, it's a forced crash. Apparently malloc detected an inconsistency with the next size and decided to bail out and stop the execution before something worse happens. But this still means we should have corrupted something on the heap. So here is the backtrace. Those functions were executed and eventually led to the abort. These functions are from malloc, so from libc. The last function from sudo itself was sudo get group list 2v1. And when we use up to get into that stack frame, GDB can also show us the source code line that caused the crash. And in this case, this function tried to reallocate something, but then malloc detected a heap inconsistency and aborted. This means we did have caused some kind of heap corruption. This is exciting, but we need to understand this crash better. Is this a variant of the sudoedit vulnerability? Or is this maybe a new different sudo crash? I'm too scared to say it is, because most likely it's not a new 0-day. But the test case did not contain sudoedit. But let's not get prematurely excited, we need to investigate it more. You can find the crashing input on GitHub in the episode folder, so feel free to play around with it. Maybe you figure out what happens. So pause the video now before I spoil it to you. Go, try it yourself. The first quick test I make is to see if the latest sudo version on Ubuntu that has fixed the known issue also crashes. If that's the case, we would know it must be a 0-day. To do that, I take the AFL2 pseudocode we wrote and use it outside of Docker on the host system. I just have to adjust the sudo binary location, then we can compile it and use the crash we found to execute the sudo wrapper. And we don't get a crash. Aw. Of course, I'm hoping to discover a cool 0-day, but it was kind of clear to me it would have been too crazy. So it might be a variant of the sudo edit vulnerability. But still a curious variant, because it seems to not include sudo edit. Remember, sudo shows different behavior when executed with sudo or sudo edit, and you can clearly see that the prog name is very messed up, and the help output is that from sudo, not the one from sudo edit. So this is really curious to me. Anyway, this test case we have is pretty complex, and probably most of the data is here useless garbage. So I would like to minimize it. Minimizing it can give us a shorter proof of concept crash that's much easier to work with and to understand. In the AFL++ README, you can find a section about minimization of test cases. I have no experience with any of them, kind of want to try them all, but I guess I start with the actively maintained half-empty project from Google Project Zero. To use it, we have to create a small wrapper shell script that checks if the input crashed the program or not. The example checks for the return value 139, which is the value of a segmentation fault. But in our test case, we don't have a seg fault, we have an abort, which has a different number. We can check the return value with echo $? And it is 134, so let's modify the script accordingly. And then we can call half-empty with the minimizing shell script and our crashing input. But somehow it doesn't work. Strategy failed. Try it yourself to verify it's working. Use this command. And I did, and it seems to work. The return exit code of the script is 0. It should work. That's weird, so I give up. Let's move to another method. How about afl-pymin wrapper? It seems to be a wrapper around afl-tmin. So let's try it. Adjust the tmin path. Let's go. Done. It created an empty output file. Huh? Maybe an empty input file also crashes it? But testing that empty file doesn't work either. Okay, let's just use the minimizer that comes with afl-tmin. You have to give it a crashing input, a location where to write the minimized file, and then the instrumented binary. Now let's run it, and it goes pretty fast, which I thought meant it must have failed too. But when looking at the file with hex dump, wow, it's very clean now. 0 edit and then -s, some characters, and a backslash. This looks like the sudo edit vulnerability. Let's try that one with sudo. We can switch to the regular unprivileged user. Then we symlink sudo to 0 edit. Then the prog name runs with 0 edit program name. And when we call it with the parameters like in the input file, keep in mind that here in the shell you need to escape the backslash, it will crash, like sudo edit crashes. It's very curious though that just calling 0 edit shows the sudo help stuff, not how sudo edit showing the sudo edit help stuff, but still seems to go into the sudo edit argument parsing code and then crash. We can also play a bit with the name and try different variants, and it's really weird why it works. It's not like the name can be anything, it's weirdly specific to be added with at least one character before it. I already mentioned in a previous video that there is this check that only compares the end of the prog name to be added, but I only knew this from exactly these test cases, so this is where I learned about this behavior. Now that we have a minimized test case, we can investigate this further. As mentioned, we are crashing when sudo tries to call realloc. It detects that some metadata value is invalid, which means the heap metadata was corrupted and overwritten sometime earlier in the program. So now we need to figure out where exactly the heap corruption happened. You can give it a try yourself. How would you find the true location of the overflow? Next video, I show you how I have done it.